Welcome back to the lab, welcome back to EEforEveryone. The start of a project is always fun, and today is no exception. I'm here today with daring dreams, happenstance hopes, awkward ambitions. We're about to do something. Hold on to your hats, ladies and gentlemen, because this project has legs. Well, wheels. Probably. This video is the start of what is hopefully a long series. I threw out a teaser a few weeks ago and you all shared some thoughts. I've been reading your comments as I prepared this series, and I think we just might have a little bit planned for everyone. Rest assured, this series is focused on circuit and system design principles, especially of motor control circuits, which of course will lead to voltage and current sensing, speed and position sensing, control loops. There is a huge depth of complexity waiting right behind the simple concept of motor control. Thank you again for challenging me to do things that are hard, like field-oriented control, because everyone needs that push sometimes. So thankfully, I'm going to sprinkle a little bit of Ryan into this project to make it uniquely, well, EEforEveryone. See, I've recognized a bit of a problem. I've wanted to do some projects involving motion, specifically rotational motion. The specific project doesn't really matter. This could be for a line follower robot, a 3D printer, a bobbin winder. Certain applications require different motor types and power levels, such as a brushed DC motor, stepper motor, or brushless DC motor. That aside, the task of regulating speed, position, or approximating these parameters is something that happens all the time. Similarly, the general information of moving a particular distance or moving at a particular speed is communicated often. Like in general, motor control and motion control is a very, very common design challenge. Engineers, makers, and people in industry tackle this problem all the time. Engineers, now we're pretty lucky, generally have a deep understanding of how motors work. Engineers usually have plenty of time to develop a custom solution for motion control because someone's paying them to design it into a product that serves a purpose. Folks in industry are lucky too, whether it be for factory automation or otherwise. There are giant motors and variable frequency drives or motor controllers that are engineered to be controlled over things like Profinet or EtherCAT. Naturally, those high power solutions are expensive, big, and expensive. Did I mention expensive? The cost is generally irrelevant for someone in industry because that one-time cost is being used to generate a revenue stream or reduce operating costs for a business. Hobbyists are, well, in my opinion, kind of forgotten about at the moment. They're often left to cobble something together out of motors and motor controllers, hoping to get it right by following a guide somewhere. It's a guide they probably found on the internet. And I'm starting to see some momentum here. I see some articles about someone designing a 3D printer extruder that's controlled over CAN, but this isn't a 3D printer problem. This also isn't a stepper motor problem. This is a motion control problem. If there existed a motor control or motion control platform where someone could feasibly write a script that's light enough to run on a simple 8-bit microcontroller, and perhaps that script could be used to drive everything from a brushed DC motor open loop to a brushless DC motor with field-oriented control closed loop, and everything in between, I think that platform would be something that I would tend to use in my projects, simply because I'd know that I could count on being able to build or buy a motor to meet my needs and just be compatible with that ecosystem. Like, if I start down a path and I need to change because I got something wrong, it's really great to know that you can go from something cheap, easy, and quick to something that's more reliable, lasts longer, and is more precise. That kind of flexibility with that universal tie is pretty cool. Of course, there are some pretty substantial problems with a goal like this. Some people need the ability to home a motor and have absolute position control, like for a 3D printer. Some people need to synchronize starting and stopping multiple motors at different speeds to achieve complex motion, like for a robot arm. And some people just need a motor to move for as cheap as possible or throw something together as quickly as possible. Proof of concept prototyping stuff. To say that accommodating all of these needs is going to be a difficult task would be a gross understatement. That is why this is a video series and not a video. For the first time in EEforEveryone history, I am going to attempt to establish a pseudo-standard for motor control in the hobbyist market. Fair warning, this will likely fall on its face and go nowhere. Some derivative of this might end up gaining some traction eventually, or who knows, maybe we'll get it right on the first try. I don't know, but if you have some thoughts, questions, or comments on this concept, let me know in the comments. If this sounds like something that would be useful to you and you'd like to partner with us on this journey, also let me know. This type of a modular system leaves a lot of room for tweakage, making it work for you. In short, that's the dream. Now it's time to turn this dream into reality. Thankfully, I've done just a little bit of research into some of the standards and communication protocols that are generally associated with motor control. Again, it seems like most of the solutions are in the industrial space with controllers and motors starting around the $1,000 US range. Profinet, EtherCAT, and Modbus are some of the protocols that stood out to me as having some mindshare, some traction in the market. The reason why I wanted to start this project with the communication interface is because choosing a foolish one will make this project a failure before we even start. If we pick something that no one's ever heard of before or is too simple, it's just not robust enough for a motor control application, if the communication protocol lacks critical features that we need to make this system work, well, we've kind of failed before we started. It doesn't matter how great or precise the motor is if the premise of the project is broken. Ethernet, specifically Power over Ethernet, is incredibly popular for powering the motor controllers and communications interfaces for this type of a system, which isn't too surprising. There's something so satisfying about having a single cable that daisy chains Power over Ethernet and communications to multiple endpoints. Motor power is provided separately, which makes sense because power. There are a lot of details that I considered, and I don't want to get too lost in those details today. We'll kind of hit those piece by piece as we go. So I just want to run through a list of things that I liked and didn't like about what I found in these different protocols. EtherCAT, Modbus, and Power over Ethernet are open standards, so that's where more of the comments to follow got inspired. I really like protocols that define clear activity and error codes and LED blinking patterns. I think that's really helpful for setup and general debugging of a system like this. I also really like when data and power are provided on a single cable, and when they use a standard cable in a way that is still compatible with existing equipment that is not powered. That is awesome. I appreciate protocols that are flexible enough to support file transfer protocols and motor controllers on the same bus, but I've generally found that protocols with that degree of flexibility and throughput take on complexity and cost challenges. I don't love standards that demand specific hardware features like requiring an EEPROM, just because if your application doesn't need it, that ends up adding unnecessary cost. There's a huge difference between the microcontroller and the hardware required to turn a simple DC motor on and off, and something that's doing complex wave shaping or PWM modulation with a three-phase sinusoidal output for a stepper motor. There is a huge difference in the amount of processing power and features required there. If we put some kind of common hardware platform underneath this, you're either going to have something that's underpowered for your complex application or overpowered for, well, the other one. Those are just a few factors that I considered, but I feel like a generally good choice was made obvious. Modbus, especially when considering that it supports both a serial and TCP/IP version, that seems like a really good choice. At a minimum, the serial-based version of Modbus includes a CRC for error detection. At its best, though, Modbus includes automatic retransmission or guaranteed delivery for every packet, rejecting invalid commands in the serial version, and throwing an error in that case is probably the minimum bar that we could accept for motor control. When an error occurs, it is much better to have a system stop instead of moving in an unpredictable way. The simplicity of a serial interface, whether that be UART or RS-485, that just allows for the simplest microcontrollers to interface with the system, and for cheap. An Ethernet-based protocol will allow for debugging with a standard PC and Wireshark, which seems amazing, but it'll always cost more. Every single motor will cost more because of that Ethernet interface. All this to say, I couldn't really decide whether having something Ethernet-based and TCP/IP-based or having something that is serial-based was better for what we're trying to do today, but I really like the balance of being able to go either way with Modbus. Seems like a great start and relatively simple way to build up to something that's more robust if necessary, and at least it's good enough to start with and explore further in our future videos. All that said, I think it's conclusion time. There are a lot of problems left to solve in this project. We need to find a reasonable physical connector and decide what cables to use. We need to think about power conversion and start discovering the limits of Modbus to make sure this protocol will actually work. I haven't worked with Modbus before, and this standard has been used since 1979. My intention is to start with hardware development kits and just learn as much as we can before building our own PCBs. We're starting with bubblegum, baling twine, and development kits for prototyping. We're working towards a polished ecosystem here, but you need to start somewhere. And there's a lot to learn before we start rolling PCBs. All of this and more coming soon to EEforEveryone. As always, I'd like to give a special thank you to our channel members on Patreon and YouTube. I really appreciate the extra step you've taken to support us directly. I'd also like to thank you all for your support through viewership, comments, sharing what we do with others, those who choose to watch with ads enabled, and those who are subscribed. It has been awesome and humbling to watch this EEforEveryone community grow, and that simply can't happen without you. So most of all, I hope that you learned something great today, and I hope to see you again soon. Thanks for watching EEforEveryone, and thank you for staying till the end. Bye!